Hello, everybody. I welcome you all for the session on AI series. Like, this is going to be on all Thursdays, but sorry for last Thursday we missed because of some reasons. But it's fine that we'll be continuing the same old hustle of giving you this series of sessions. And this is the first session that we are doing, and second session will be on the Thursday. So do check out that. And as you know, it's azdev.community right now, and a lot of events happening. We are a community which is strong. It's like 8,000 plus members and 8,500 plus actually. We are growing pretty fast, and the only motto behind doing all such kind of event is to learn, network, upskill, and make sure that we all come out as a future ready engineers. And there is a subscription, so please do consider subscribing to all the things that is going on, and everything will be notified to you through the mail. And also it's a very cool website to visit, and if you guys can visit and see, if you guys can do some clone of it, it's obviously good to go. And there are some partnering communities, there are some communities here, and there are some past events, and there is obviously upcoming events as well. So it's all from the AZDev Bangalore chapter, so you guys can join. And I think all the events are tailored in such a way that it is going to give you a lot of insights about this tech. And there's Peter Treatment who is coming up, the boss of the DevOps and the SRE. So if you guys want to check out, please do check out. Coming back on 27th, I think so, if I'm not wrong. But yeah, it's our event, but I forget the date. Sorry for that. It's on 27th, so you guys can just hop in, just ask him as many questions as you can. It's amazing actually to get such kind of people onto the events and things like that. So there are community organizers, so you guys can come, hop in. And there are speakers. So my favorite section, if you guys want to just hop in as a speaker, do let us know. We'll just make sure that you will be a speaker. And that's it from my side, folks. And over to you, Priyanka, ma'am. It's all yours. The stage is yours.
Hey, thank you, Vishwas. Impressive lineup of speakers and sessions. All right, so yeah, keep up the good work.
Thank you.
All right. So yeah, can you put my screen sharing also? Right. Correct.
Yes.
Hey, hi, folks. Hi, and welcome again. And today, we will continue with our first session in the series, which will talk about lot of things, which is AI and ML, right? And yeah, so let's begin without much ado. Today, the session would be on practical applications of AI, which is just hold on. I need to change. Yeah, so this would be practical AI applications, right? So we would be discussing about how AI is actually being used in projects, in applications across organizations, right? So we talk a lot about AI and ML in data science, but let's see how it all comes together, and we are actually leveraging on AI and doing something practical, something tangible of organizations, right? So when I say enterprise document search, we will be talking about a lot of good things, a lot of exciting things like text analytics and the document tracking and indexing and leucine index and breaking down words to their roots, right? Semantic search and stuff. Right? So it will be a fun session today. You'll see a lot of demos, hopefully, right? So let's jump in. I won't bore you with the basics, right? So this is about me. And the agenda for today would be something as follows. We would be learning about Azure Cognitive Search. Okay, the concepts of not only Azure Cognitive Search, the concepts of natural language processing, and basically how do you go about searching documents, right? Then how to handle mixed mode and add AI enrichment to your documents, and demos will be all interspersed, randomly together. Okay, so uh, let's jump in, right? So actually, when you typically look at websites nowadays, right? So what happens in websites is basically when you're looking for something, you will want to have a very uh, nice and intuitive sort of search, right? So when you're looking for jobs, for that matter, right? Then you will be looking at search by certain keywords, or you will need auto suggesters. Like as soon as I'm typing business, analyst or analyst, then it should pop up with suggestions like data analyst, business analyst. I should have some sort of segregation at the yeah, side here where I can group my results like according to salary or according to the number of days the job posting was active or the number of roles for that particular profile which I'm searching for, right? And then I should also be able to sort it according to relevance or according to price. I mean, not price, according to salary, low to high. There should be paging of my results, and there should be some sort of geospatial search available to me, which means like I can zoom into the location. So if I'm searching, so it's a job website, and I'm pointing at some location in Florida, and then it should go and search for job openings there. Or if I'm looking for Microsoft jobs in North America location, right? Then I should be able to point something somewhere on the map, and it should pop out the relevant region, and if there are any vacancies or job postings available there, it should pop up. Okay, so typically users, end users, consumers are looking a lot of these functionalities in your search applications. It's not just plain vanilla search where you enter a keyword and it is bringing out all the documents or all the text which is having that keyword there. So the search engines or search applications are expected to be smarter, a lot more smarter than they were like a few years ago, right? So just let us look at one such demo, the site which we are seeing here, right? Let us look at the demo there, and let us see, how it works, and then we'll get into the nitty gritties of all the moving components which come together and work in tandem to make this powerful search a reality, right? So let us look at yeah. So let us look at uh, the job search website here, correct? Right. So maybe I'm going to search a job for AI, right? And then okay, so if so it's, for example, if I'm typing, then it will pop up with suggestions. So something which has the word AI or starts with AI. Okay, right? So it is now I mean, or let me start with .NET something, right? Maybe, yeah. So .NET, and then it will pop up with .NET programmer analyst, junior .NET developer. Then since it is .NET, it will also pop up with network administrator. So this is a sort of type ahead, right? Or suggestions. Typically, what you see in Google when you're trying to search, and it also takes care of spelling mistakes. Okay, so when let's say I'm typing analyst, and I type like something like this, but it still knows that I'm searching for an analyst, so staff analyst. So this fuzzy search, which we call, wherein it takes care of the spelling mistakes, right? And it will still give you the correct suggestion. So let's look at analyst here. So analyst role. Now any distance from within 1 kilometer, 5 kilometer. Okay, this is your geospatial where I'm looking at uh, a particular location on map and searching there, right? And then you have filter results with the business title, location, right? So maybe, let us look at this analyst and let us search. Okay, so now whatever you see on the left hand side here, these are called as the facets or aggregators, right? So these enable you to filter out your results on certain criteria. So let's say if it is a hotel booking website, right? So on the left hand side, you will see aggregators or facets, which are like number of rooms, or the price range of the hotel, or certain other features like the number of rooms in that hotel, or whether it's a garden facing or ocean facing, or a presidential suite or executive suite or small room or double room, those sort of so these left hand side fields which you see are enable you to sort of group your search results together, right? And then you have filters here where you can filter by, I mean, order by relevance and salary, and which is not uncommon what you see in your Amazon or whatever you see in your shopping websites. And then you actually have the search results wherein your key term is highlighted. So this, you're searching for analyst, and you're searching for analyst, and then you can click on read more, and then actually go to the details of the job. So what you see here is like initial what you see here is the initial description of the job. You have paging results here, and then you see your search term highlighted there, like you're searching for analyst, and then it will highlight the search term analyst. And once you click on the actual links there, you might go and it might show you the details of the job, right? So this is typically what your websites today enterprise search is looking for, right? Now let's say so let us look at a scenario here where I have enterprises which have actual documents with them. So this is still like this is still I mean doable in the sense that job descriptions are not so extensive, right? So maybe couple of page of documents, and maybe for an organization maybe not more than 1,000 openings, right? So those I have to index and then search within them. It's still not a Herculean task. Just imagine when I have like maybe 5 terabytes of data spanning 20 to 15 to 20 years in an organization, and it could be a sort of mixture of documents across different data sources. So some are on premise, some are on cloud, some are on other databases, like within SQL or Salesforce reports. Okay, so which means I have to collate data, aggregate data from a lot of diverse disparate data sources, bring them at one central location, then gather all the documents, the text of the documents, and then index it. Documents could have images, documents could have embedded videos within them, and then I should be able to ingest all of that and have search on top of that, right? So it's not uncommon for organizations to come and ask us that, hey, I have all these documents, I have for data for 15, 20 years. My documents are of different types, like I have CVs, I have project sheets, I have news articles, I have legal contracts, right? I have certain other Excel spreadsheets which are just numbers. I have PDF documents wherein I have certain tables which I want you to extract out the data for me and present me the results, right? And then the expectation is that because of all these documents which are spread across such a long period of time, the data which is there within those documents has a lot of latent potential, right? So the expectation with analytics and AI is to be able to search that data. So if I'm looking for, let's say, one particular project which was valued over 15 million in the last 8 years, okay, and then my search, my AI should be able to interpret that today is the year 2021. So when I'm looking at last 8 years, which means I'm looking at somewhere 2014 plus, 2014 and prior to 2014, right? And then if I'm looking for, let's say, 13 million, which means it should be able to translate the 13 million as 13 into 10 raised to 6, and try to search documents with that project value, right? So there's a lot of expectation out of your AI algorithms, your search engines, and that is why more and more powerful tools. So you have Azure Cognitive Search, and you have inside that you can add a lot of cognitive services to it, AI services to it, package other AI services, and use Azure functions to impart custom machine learning to it. So we will see few of those capabilities today, like how it is possible to actually bring in this sort of functionality for document enterprise document search. All right. So let's proceed, guys. I'll need to keep on doing this. That toggling the view. So I need to. Yeah. Cool. Yeah. So this is what we saw, the expectations. Now, what is Azure Cognitive Search, right? So this is nothing but search as a service. So it's out of the box a service wherein your enterprise search is given to you as a service, and it's a set of APIs and tools for adding a rich search experience, right? So you can connect it to your content in web, mobile, and your enterprise applications. So typically how it works is, this is your data, which could be in the cloud or behind a firewall, which is on-premise. On-premise could be SharePoint, could be on Windows file, could be in SQL, right? So your data could be anywhere, and you have a lot of data ingestion tools in Azure, which is your data factory, Azure Data Factory, in which you should be able to collate your data, bring it to a data lake or a blob storage, and from there you will index it into Azure Cognitive Search. So just imagine a part. This is your data, disparate data sources. You are collating it, ingesting it into one central location in the cloud. From there, you will have Azure Cognitive Search. So you will index it into the Azure Cognitive Search, okay, and then you will be able to require. I mean, you will query your data as a REST API, right? So from the UI, you will be hitting your cognitive search engine, and you will be querying out your data, okay. So what happens basically is all your documents which you have. So I might have Word documents, I might have PDF files with images in them, I might have PPT files, I might have Outlook message files, right? So any sort of data. What happens is when you're ingesting it into the Azure Cognitive Search, the text, the plain text, the vanilla text within all those files is pulled out, and it is stored as a base 64 encoded string in one particular field which is termed as content, right? So content, and if there are images and I might want to extract images and do optical character recognition on those images embedded inside the documents, then that is also possible, right? So when you are ingesting all that data, okay, so let's say I have a very simple case, I have a document, okay, I have the simplest case, let us take that I have 10 documents, okay, they are talking about music. So I have artists and I have musical instruments and I have what is this I mean files about artist, file about musical instrument, file about his album, right? So some sort of JSON files, let's say. So I have 10 JSON files related to music. Now, when I say that I'm ingesting those JSON files in cognitive search, what it means is the data of those JSON files, I'm taking it and I'm putting it as a base 64 encoded string inside my index. Okay, so we'll come to what is index. So I'm putting it inside my index, right? And then I am enriching it with certain out of the box or custom AI enrichments. What do I mean by enrichment? So before I take my data, so let's say my first document is about a particular group, okay, so let us talk of the Beatles. So it is about the Beatles, so it is talking about who are the members of the Beatles and what are the albums of the Beatles and what awards they won. So it's maybe a JSON document of maybe a few 100 lines, okay, of text, and it is talking about all these things. Now, before I just ingest the text, what I can do is I can perform some sort of enrichment on that, meaning I can extract entities, right? I can extract out entities from the document. So, names of people, celebrities, landmarks, locations, geospatial indexes if there are any, indices if there are any, and important keywords, key phrases like they delivered 10 hits or they earned so much, or XYZ was the lead drummer or the lead player and they were into this genre of music or hard rock or stuff like that, right? So before I actually just extract the content, okay, the 100 lines of text which is there inside my JSON file, I can do some sort of AI enrichment wherein, first is text analytics, as I talked of. You extract out personally identifiable information, landmarks, celebrities, people, or keywords, key phrases, right? So that can be done by a cognitive service which is called as text analytics. If there are images and you want to extract out the images and may be able to read optical character, have the ability to have optical character recognition, can still have that, right? So that is also another cognitive service which will be able to read the images. So your custom vision will be able to extract out the images and OCR and do that, right? So before I just ingest the plain vanilla text, I can do these AI enrichments. So this is what I call by standard or AI enrich. There are certain capabilities which are out of the box, like text analytics is out of the box. So when you're ingesting the document, that time itself it is asking you, do you want to apply text analytics? Do you want to apply image processing, right? But there are certain higher order natural language processing if I want to apply. Like, I might have a Spark modeling on top to extract relationships. Okay, so I might have to extract like if those 10 documents are talking of the artist, the album, and the genre, right? So I would want to have that this particular artist plays this type of genre, and he plays this type of instrument, and he was performing in XYZ album, right? So this sort of entity extraction, if I have to do, I might have to apply higher order machine learning models or natural language processing models, or if I have to have a possibility of semantic search, meaning, if I'm trying to search for uh, similar words, right? So maybe that exact phrase is not there in any of the, if I'm trying to search for hit albums of XYZ, but that hit albums phrase is not there in any of the documents or any of the text which is available. So it should know that, I'm searching for popular albums, or I'm searching for albums which got some international recognition or had a lot of viewership and stuff like that, right? So that sort of semantic searching, word semantics, all of those will require higher order. So my before I just ingest my document inside Azure Cognitive Search, I can have all these enrichments done to it. Okay, and then once my content sits inside nicely in my index, right? Then I can just have the ability to query that index using .NET SDK or REST API, and get back my search results. All right. So as you saw in our website, which was the job search website, right? So you are searching for analyst, and then it is surfacing out all the results with the term analyst in them, and giving you all other uh, 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 facilities like faceting and filtering, sorting, paging, right? So this is about Azure Cognitive Search, right? So it is exposed to us via REST API. It provides administration and content management support. Like, if, for example, you need to have security. Like XYZ group of people cannot see confidential documents which are related to legal contracts, or maybe only HR people will be able to see CV related documents. So all those things can also be done. Okay, and because it is running natively in the cloud, all the infra is managed, and it's supported by Microsoft, right? Okay, now a lot of people come and ask us, like, does cognitive search replace my RDBMS or my unstructured databases, right? So my NoSQL databases. So is it a substitute for Cosmos DB, or is it a substitute for relational databases? No, right? So it could be that sometimes Azure Cognitive Search might be used if in tandem with your relational database. So I have some part of my data about my documents in SQL. So let's say when we are talking about this music system, right? So this music system which we are building. So I have all the text, like, the files about the albums and the artist and the music. So all these files, JSON files I have, but my metadata, which is to say that the year of the music, or certain things about the music could be stored in my, or the location of those files could be stored in my SQL database. And I, when searching out, I would be able to surface both of them. So I'll search in SQL also, I'll search in Azure Cognitive Search also. Azure Cognitive Search will bring me back my my text, and then the SQL might bring out other results, where that XYZ album or artist performed in this album in the year before 1983, or stuff like that. So it totally depends on the type of business problem which you're trying to solve. Okay, so when let's say when to use Azure Cognitive Search, you have a lot of content, heterogeneous content, lying across different data sources. Okay, and then you need to be able to have these sort of natural language processing to be used on your document. So for very simple use cases where you want to search a very small system which has a pretty predictable and structured data, right? So maybe just your normal databases might suffice. Okay, but like this case where I have files in image formats, or in audio formats, video formats, and from that I should be able to extract out meaning, or apply word semantic search. Or even better, nowadays with the advent of OpenAI GPT and Word, what is happening is that you have huge text corpora, and from there people are expecting that if I ask a question, so let's say, for example, even children's story books, right? So if you feed all that content of your novels and children's story book to your machine learning algorithm, and then you ask a question like why did Alice follow the rabbit, just thinking aloud, right? So why did Alice follow the white rabbit into the burrow or stuff like that, and then the AI should be able to understand that you are now talking of Alice in Wonderland, and it should be able to surface of that answer. So imagine that for an algorithm which has ingested over a million of pages of storybooks, just to understand the question and then give me back the correct answer. Maybe it is quite evident in the text, or maybe it is not very evident in the text, right? So it has to maybe, the answer may be in page 1 of my storybook and page 10 of my storybook, and then it still has to understand that what I'm asking for, and then try to bring the content together and show me a coherent answer. So if this is your requirement, wherein you need to sift through a lot of natural language, you have to navigate a lot of natural language queries and get back your answers, wherein you have document search, you have context based search, you have Q&A. Okay, you want to have bots to have your surface out user queries, right? So for those kind of things, I'll recommend you to use Azure Cognitive Search. Okay, so whenever you have unstructured text and NLP based functionalities or features which would serve your purpose the best, go for cognitive search, right? For all other things where your data is limited and your data has predictable structure, uh, often, more often than not, your SQL should be enough to surface your, I mean, to address your needs. Okay, so the search features, as we saw, was free form text search. So you just type something, it will give you back. Geo search, filters and facets. User experience features like type ahead search, suggesters, right? AI enrichment features like text analytics and like having image features like OCR detection and stuff. Okay, and knowledge store. Okay, knowledge store will come to that. What is knowledge store? Now, before we go to the knowledge store and stuff, let me show you another. When we talk of the when we talk of right when we talk of cognitive enrichment, like I talked of text analytics, right? So when I talk of enrichment, which we do to our data, right? So let me show you what it is capable of. Okay, let us take this is the music file I was talking of. You have also, this is an open data set, right? So this is a Wikipedia music data we have crawled, and we have gotten JSON objects here. So which some are albums, some are songs, some are artists themselves, right? So let us, for example, look at this. I'm editing it. Okay, okay. It's no content here. Wonderful. Okay, let us do uh, this file. Okay, and then see content. What's the story? And I just copy something, right? I'm copying out the content where it is talking about what's the story morning glory, right? Correct. So this is the demo website for text analytics, which shows us what it can do. I'm just going to refresh it, right? So you know that it's not scripted. Okay. Right. We copy our text here because it's a demo. I think there is some certain text limitation. Okay. What the text analytics can do now. So this is out of the box. Okay, so this is when you are ingesting your document, it will ask you in the while you're building the cognitive search that do you want to add text analytics. You say yes, then this is basically what it will do on your text. Okay, so this is what we call as document tracking, meaning before ingesting the document, it will apply enrichments to the document. So when you say text analytics, see what it has done. You gave the text. What it has done is it will first of all give you the sentiment of the document, whether it is neutral, positive, negative. So here it's just a fact-based message, right? So you're just giving facts about the particular album here, right? And that's why the sentiment is neutral. Second thing, what it has done is look at the highlighted text here, which is the text in blue. So it has surfaced out keywords and key phrases. So this is the inbuilt AI NLP algorithm of Microsoft, and it is surfacing out keywords, key phrases, and it is also surfacing out entities, I mean, people, location, organizations. So Owen Morris, Noel Gallagher, or drummer Alan White, or Tony McCarroll. So whoever are the personally identifiable information, or landmarks, or celebrities, or location, or people, or organizations, it will surface out those. Okay, so now I know that whenever I'm talking about this particular document, these are the important features or important metadata about these documents, right? So it has surfaced out that, and then when you go to the next step, what happened? I don't know what happened. Just let's, okay, right? So when you go to the next step, okay, sorry, this is okay. So this is the I mean, the text analytics with the default text here. So it's the same thing, it has surfaced out the keywords, key phrases, and when you do next step, what it is going to do is it is going to do entity linking. Entity linking means it will try to now give you more information about whatever keywords, key phrases it has surfaced out. So Saturn, Sun, Jupiter, solar system, Earth, and it can give you links here where you can have a deeper search. Also, this is connecting you to the Bing search, right? So you can get information about this on Bing search and surface out more information. So this is entity linking, right? So this API, which keywords are entities and links them in Wikipedia. So this is bringing out your entities, okay, and these can also be a part of your metadata, right? So the album which we saw, all the players like Alan White and Gallagher, and the name of the album. So that becomes your metadata. So those are your entities extracted out of your document, and on that you can do additional processing, right? So I can use that as a document tag in, like how you see in Stack Overflow or all of your Twitter or social media websites, right? When you are hashtagging your tweets or you're hashtagging your Facebook post, LinkedIn post, that becomes a metadata about your post or your tweet. Same thing, like these all will become the metadata about your document. So when I'm searching now, it will be very easy for me. So when I'm trying to search that which are the albums in which Alan White was the drummer, okay, and then it will surface out all these documents because it already has Alan White as a part of its metadata. Got it? So got the context of what I'm talking of. I mean, out of the box text analytics. So this is a wonderful thing to have. So not only just ingesting your document vanilla text, but before you ingest your document, you can have all these wonderful natural language processing done on your text. Correct? Okay. Now we come to a very important and very how should I say, intriguing part, which is done for Azure Cognitive Search, and that is called as Semantic Search. So I just right now, I talked about a particular engine wherein you are feeding it millions of pages of text, and you are searching for a particular question, and if that answer is somewhere within the text, it should surface out that answer and show it to you. So that particular functionality is now out of the box in Azure Cognitive Search, and it is called as Semantic Search. So it's still a preview feature. It will be GA soon. Okay. So it's now available to a select set of people who are actually trying to understand its implications, its use. So I have access to that preview right now, and I'll show you the power of semantic search. Okay. So if in the power of semantic search, I'm, because it's in preview, right? You don't have a what to say. You don't have a open demo here, so you need to implement it in your code. Because now we are talking already about music demo, right? So let us see how Azure Cognitive Semantic Search works. So this is my same semantic site, and just to show you that these are the almost around 1,000 documents we have ingested. Okay, so they are talking of a variety of rock bands and albums and songs. Okay, and so it has a plethora of information about all the music open data source that is available in Wikipedia. Okay, now if you imagine that I'm just asking it a question like who plays hard rock, or who are the members of the band ABBA, or who are the members of Beatles, then there is, from all these documents it should understand that, okay, I'm talking about who all comprise the band beaters, who all form other members forming the band ABBA, right? And then it will try to give me that answer. So let us look at that. Okay, so who are the members of ABBA? I'm searching, right? So this is going to my index is the table which is there in cognitive search. So it's not a table, I should not say, but just to relate it to SQL. So this is your table in SQL. Okay, so this is your index in cognitive search. And when you do that, if I'm going to F5, right, I just want to show you because as I said, you won't find any open website here with that demo. So now if it has answers, right? So this is my search text. What was my search text? Who are the members of ABBA? And in my result, if I have an answer, it is giving me that, yeah, your question, it returned an answer. Okay, and it has an answer. And what is the answer? Okay, so now if you look at the answer, ABBA are a Swedish pop supergroup formed in Stockholm, and these are the members of ABBA. The group's name is an acronym for the first letters of their names. So it exactly knew what I was asking for. So it just didn't do a keyword search. Mind you, there's a difference, right? When you're doing, so when you're searching for analyst job, or when you're searching for the keyword ABBA, okay, it could have surfaced me any document which has the keyword ABBA in it. Okay, it could be also because it could be like if I'm doing a phrase search, it can also be that ABBA is a term in between a sentence, okay, or in between a big word. It didn't do that. It understood what I was searching for, not only just keyword search, and it gave me a very coherent and correct answer. Okay, so if you look at the other properties of that answer, it will also give you the answer score, like what is my answer confidence, right? So for the score is, it is 99% confidence, so almost 100% confident that this is the question you asked, and this the answer which I gave you is actually 99% probability the correct answer for your question. So this is the beauty of semantic search. Okay, so this is all higher order natural language processing, which what you find in your BERT, right? Your BERT models, your BERT squad, and your sentence BERT, and your Q&A BERT. Okay, so all of those are now available as a semantic search functionality in Azure Cognitive Search. All right. So yeah, I mean, just wanted to show you that. Okay. Yeah. Again, coming to other features which typically organizations increasingly ask us, right? So it's not just about semantic search is one part. Keyword search is anyways, that is what I mean, something which is second nature. So if I have a search engine, document search engine, by default it should be able to do keyword search, right? But not only keyword search, it should also be able to do I mean, apart from exact semantic search, it should also be able to do search for related terms. Okay, what that means is, like I said, if I'm searching for something like negative reviews, right? So negative reviews for a particular hotel website. So there's a hotel or a lodging boarding website, and I'm searching for negative reviews. So reviews which are talking of dirty, or which are talking for unhygienic, or which are talking of unfavorable, they all fall under the negative reviews bucket, right? So synonymizing. So synonyms for unhygienic or dirty or unfavorable are all negative. And so what comprises negative reviews? So understanding that, having that facility for identifying synonyms. So group words which are near to each other. So the cosine distance between the words. So if I talk in the terms of natural language processing, machine learning, so words with cosine distance between, I mean, cosine distance, lesser cosine distance are semantically related, right? And larger cosine distance are not semantically related. So if I look at good and bad, they will be at the opposite end of the spectrum. But maybe good and neat and clean are will be together in that particular context. So not in generic, in one particular context what you're talking of. So all these semantic word semantics and heuristics, they come into play when I'm talking of synonyms, right? So this is a COVID-19 Azure Search website, all right. And when I'm talking of COVID-19 Azure Search website, let me example search for. So this is see how this is type ahead search. So I am talking of ibuprofen, okay, and I search for ibuprofen, okay. So then it will give me documents which are talking of ibuprofen, which is correct. So this is your keyword based search, okay. So this is ibuprofen. Now it will also give me semantically similar terms. So ibuprofen and naxprosen, NSAID, paracetamol. These are all also maybe semantically similar. Not maybe they are semantically similar to ibuprofen. Again, when you search for ibuprofen, there was some metadata which was extracted out, okay, before indexing these documents, these COVID-19. And this is a medical domain, right? So before indexing these medical documents into Azure Cognitive Search, there was certain metadata extraction, like in the case of our music demo, we extracted out entities and we extracted out our players and bands and stuff like that. So some sort of metadata extraction was done here, okay. So contributors for documents which have ibuprofen inside them, or journals or for articles on which ibuprofen was mentioned, okay. Now it also gives me two very nice functionalities. One is explore graph relationships, and second is semantically similar terms. So these things you already saw, right? So this is faceted search. You are faceting, aggregating documents together, and this is your keyword search. Okay. Now you look at similar terms like naproxen. If I do that, and now if I search ibuprofen and naproxen together, or ibuprofen and NSAID together here, correct, right? So now you will see documents which are talking of ibuprofen and NSAID together in some context, I mean in some contextually similar manner. So now you see here it is like an intersection. So ibuprofen, NSAID, in what documents it is mentioned. And so it's not only ibuprofen, NSAID, it could be NSAID, aspirin, okay. And then documents having the mention of all those things, okay. So semantically this is called as query expansion. So I'm expanding my query. Ibuprofen, NSAID, paracetamol, acetaminophen. Excuse me for my pronunciation, I'm not so familiar with the medical domain. So now you see, like, this is query expansion, okay. After query expansion, what happens is, okay, so after query expansion, it is very easy for you to actually quickly search documents having semantically similar terms, and whether they are occurring together somewhere, and that's why they are semantically related, okay. So it is very easy for you to zero down on your search results, quickly zero down on your search results, okay. Now let us look at graph functionality. What happens is, when you do explore relationship graph, see, just look at so these are relationships. So so for ibuprofen, when I look at ibuprofen, then you will look at what sort of graph relationships you're looking at. Are you looking at contributors? So contributors meaning which, so ibuprofen, so this is your root node, and it is related to which other node. So which other contributors directly contributed to ibuprofen, to documents or reports mentioning ibuprofen. And then let's say maybe ibuprofen was written, mentioned in a paper which was written by Abbas Hydri, okay. Now maybe Abbas Hydri and Alyssa Morin were collaborating on some other paper altogether, but then that relation is also shown. So second order relationship is also shown, right? So just look at the beauty of graph search and cognitive search, at what all levels of data extraction and relationship extraction it is allowing you to do, and how beautifully it is giving you insights into your data. So maybe ibuprofen, as I said, was in direct relationship with these contributors, but these contributors have collaborated with other contributors on other papers, and that relationships also are being shown, right? So here also you can do this. So ibuprofen now, I want to do it on the diagnosis, right? So on the diagnosis I can do that. So this is another graph relationship we have. So ibuprofen, the diagnosis for ibuprofen. So it was used in what? So it was used for inflammation, it was used for infection, and then it was used for respiratory distress syndrome, okay, and then the secondary relationships between that, okay. So it was used for coronavirus infections, but coronavirus is also a disease, inflammation is a disease, and it is also used for treatment of these, which are all diseases, okay. So you get a lot of insights which you may not be aware of, lot of inherent relationships. You can have these insights come out to you, extract easily, okay. So you can just look at the wonderful world of NLP and semantics right in front of you, and this is configurable, and most of the things are given to you out of the box by these cloud providers, right? In our case, it's Azure. All right, let's move on. Okay. Right. So when you're actually trying to ingest the document, so whatever we discussed here are on top of I mean they are on top of when you're trying to ingest a document. So first, when you're using Azure Cognitive Search, would be to create an index. Then you load your data, then you perform all these heuristics on top of your data, and then you finally get to search your data, okay. So these are the fundamentals, because cognitive search is the underlying basis is elastic search. So these are some of the terminologies. Okay, so when you talk of database in search engines, you call it as index. So I've been talking of index your data in index, indexers. So this is an index. Index is like your database which will hold all your information. Okay, and when you're calling a partition, it is called as a shard. Don't worry about shard right now. That will keep it as a discussion at some later point of time in later sessions. Okay. Then you have row. Row is like your row in your database. So in terms of elastic and cognitive search, you call it as a document. Okay. So when I'm saying that I'm indexing a document, it doesn't mean my Word or Excel or something. So that particular, like, one full document with all its types, okay, so all the metadata, all the content inside it, that becomes a document, okay. Column becomes a field. So in my case, it will be like, fields will be the content of my document, so the path of my document, okay, the other metadata, like these things, like document tracking, so location and people and person, so those will be the fields here, okay. Again, mapping, okay, and mapping between the documents, okay. And you have structured query language, and here you have something called as query DSL, okay. So this is the language in which you extract it out. In Azure Cognitive Search, it is OData syntax, okay. Now, what is inverted index, right? So how fundamentals for how text is stored. So what makes all these searches so fast? Like, you saw that in this COVID-19, they were like more than 100,000 documents indexed there, and you just click it, search ibuprofen, and it is like in a fraction of a second your results are in front of you with all the additional wonderful insights like graph relationships and semantically similar words and query expansion and suggesters and type ahead search, right? So how does it work? So it basically is hinged on a concept called as inverted index, right? So, for example, you have three documents. Bright blue butterfly hangs on the breeze. Second document is it's best to forget the great sky and to retire from every wind. Third is under the blue sky in the bright sunlight, one need not search around. Okay. So, in inverted indexing, what it does is it takes each term and then it gives me the document and the position. So if you look at the term best, it is in the second document at position 3. If you look at the word blue, then it is in two documents. Okay, so document 3 and 1 and 3 and position 3 and 2. Okay, and then when you're searching for blue sky, basically what it does is it will try to see, okay, blue is in document 1, document 3, sky is in document 2 and document 3. So blue sky together will be in document 3, right? And then it will give me the document 3 as a result with blue sky as a highlighted term. it may or may not be together, right? So blue sky can be like blue colored sky, but still blue sky will be highlighted depending on how I configure the analyzers, optimizers, and stuff. What this is like what makes the search so fast. Okay, so you have something called as tokenizing. So this is got fans give me a shout. This is got terms. Winter is coming, so I tokenize it. Winter is coming, so this is called tokenizing, where you're not breaking my word, my sentence into tokens. Okay, I index it. Okay, as I showed in the previous example, the term, the frequency which it occurs, and the document. Okay, second is the term is ours is the query. So you tokenize it, and then again you index it. So you this is how it will be indexed. The term, the frequency, the document it will belongs. Choice is yours, right? So tokenize it, index it, right? And then when I'm searching for is coming, right? So when I'm searching for is coming, it would intersect those sets coming up with only one matching document set. So is coming, it is in documents here. So frequency is 3 and 1, and it is in document 1. And then that is how the document 1 would be surfaced out to me. If it belongs to multiple documents, then there will be scoring, right? So how many documents the term is coming, it appears more number of times, or it appears in contextually relevant scenario, right? So tokenizers, analyzers are the other layers for that can help you enrich your search, right? So as we said, first is tokenization, where you are breaking up your text. Okay, then you have stemming. Okay, stemming, which means you're breaking down the word to its root form. So go, went, gone, going, all will boil down to go. Okay, so play, played, playing will be all play. uh, Stop word removal is your removing the useless words like the and is and stuff like that, right? And all these things are also, you can define a lot more complex analyzers, tokenizers like bigram, agengram, and gram. Okay, and that can help you even get better search results. Okay, so this is a quick view on how you are going to get out. I mean, how all the tokenization, lemmatization is applied. All right, correct. And enrichment, as I was talking about, enrichment in cognitive search, as I was talking about, is before you are ingesting your document, right? You are going to apply heuristics on top of it. So out of the box stuff like OCR or text analytics, which we saw, that quick demo which we saw. Okay, so this is your all enrichment before you put your document in your index. These are the things you can apply on top of it. Okay, yeah. So whenever you are talking of a skill set in Azure Cognitive Search, so this is what the features which my text should be able to exhibit, like semantically similar words, right? Able to feature out synonyms. So if I'm or proximity words. So if I'm searching for Australia, it should help me search for Brisbane. It should help me search for Canberra, Adelaide, Melbourne, Sydney. Okay, so same for UK, it should feature out. When I'm searching for UK, it should be England, Wales, and Ireland, and okay, those things. So proximity search. So skill sets is what features you want your document to have. Okay, in our case, it was having natural text analytics, where it should be able to surface out location, people, landmarks, celebrities, geospatial things. Okay, and this is how the entire cognitive search works. So you have source data, you have document cracking. Cracking meaning you're extracting out the text, and you are storing it in base64 format. Okay. Then you have you're applying some custom or inbuilt skills like text analytics, image processing, or higher order word semantics, which we saw here, graph capabilities if you want. Okay, then the enriched documents, you can store it in a knowledge store. So this is like next time you want to have these same enrichments applied to some other set of documents, you can baseline it in a knowledge store. And you will finally store your documents in search index, and then you will be firing queries to get out results from there, right? So knowledge store is just like a feature that persists the output from enrichment into some location, into some uh, storage, and that can be leveraged for next time for others or other indexes, or when you're building a new indexer, right? Okay. Before I conclude, let us look at another. Sorry, let us look at another quick functionality which increasingly right, which increasingly websites want. So after you have built your document search engine, another feature which you would typically like to have is a bot functionality, right? So we will delve into the nitty-gritties of what is LUIS, okay, and Q&A maker, and how to build bots in our conversational AI session. But because we are talking of enterprise search, it couldn't be complete without discussing about bots, right? So people will have you, like, once you have built a search engine, then they will want to have an interface where you can ask that help me, or the chatbot there to surface out documents for you. Now, in this case, you are not going to search for just keyword key phrases like the websites which you saw here, the COVID-19 or the semantic search and the job search. You are just searching for particular words, like analyst is there or IT engineer is there. Here, you will be searching for medical terms. But when you're interacting with a bot, this is a smart home bot right now, correct? Then people typically will have different ways of putting the same question to it. Okay, so excuse me. So for example, if I want to so this is a house, and the demo here will show me that different controls. So the bot is able to understand different commands, and it will adjust the light intensity as per my commands here, all right? Okay, so if I say that please don't disturb me, then it will put out all the lights. But another person might say I need to go to sleep, so this is sleeping time or this is night time, then it will dim out all the lights. So basically, it should be able to understand the intent behind my query. So if I'm saying that it's time to go to sleep or please don't disturb, mean the same thing, and it should turn off all the lights. Or I am saying that so I'm in the living room here, and I'm saying I want to read. Okay, so which means that it should allow me, or I want to watch TV, or I want to read, then it means that I want the light on in my living room. Or there are guests coming, okay, then it should have the porch light on. So right now the porch light is off, and the porch light should be on. Or let's say I'm working in the kitchen, or I am hungry, or I'm cooking, which means the kitchen light should be on. So not only just surfacing out query keywords, it should also be able to understand different spoken words, and be able to understand that they mean the same thing. That person X saying I want to go to sleep, and person Y saying it is night time, mean the same thing, and just dim the whole lights of the entire house. So this is what increasingly your NLP and your text search and your document search engines are expected to have, and this is how they are developing and building. Okay, so let's say for example, I'm saying that do not disturb. Okay, and then okay, so if it doesn't understand your intent, then it will say sorry, I didn't understand that. Okay, so I will say I need to sleep. Okay, correct. And then see, it has dimmed all the, so if I need to sleep, then it has dimmed the light in my bedroom, right? So it has shut off, not dimmed, it has shut off the light in my bedroom. Okay, and then let's say I need more light to read my book. Okay, or I'm reading, I need more light to read my book. Then it has because I'm reading a book in my bedroom, here it understands that okay, maybe I need some light in my room because I'm reading there. Okay, or I will say dim the lights. Okay, so if I say dim the lights, it will dim the lights of the entire house, right? So it has kept very I mean minimal lights there. Okay, or maybe guests are coming, then it should know that okay, guests are coming, so I need to have all my lights bright and ready for the guests to come, right? So just I mean just you I'm expecting guests or guests are coming mean the same thing. or I'm saying that it's too dark in here, or dim the lights, and then I say it's too dark in here, then it knows that it needs to brighten up. So just understand the amount of possibilities natural language can have to convey the same thing, and then how efficiently bots understand those intents and then take actions accordingly. So this is all higher order NLP itself. Okay. And just before we conclude, if you can also call Batman, and then it will send out the bat signal. All right. Yeah, so that concludes our session on document search here. So the last part, don't bother much about it, right? So this is will cover in more details in our conversational AI series, which was just to highlight that no text engine search engine website is complete without having bots embedded inside, which can beautifully interpret your intents on top of all the functionalities which your search engine is giving you. All right. So yeah, any questions? I'll be happy to take. But as of now, the session is concluded. Over to you, Vishwas.
Vishwas. Yes, ma'am. Yeah, thank you so much, ma'am. Thank you so much for taking your time on, I think, Monday night there, and it's Monday evening here. So I think thank you so much for the session. Yeah, it was great. I think probably since everything was a demo here, I think probably everybody saw, okay, this is what is going behind the hood of that technology that she's talking about. I think there's no questions here. Yeah, thank you so much, ma'am. Thank you so much.
Thank you, Vishwas. All the best. I'll see you shortly.
Yes, we'll